So in this video today, we are going to learn about ultrasonic testing. So first we are going to learn about the basic principle behind this technique, and then I am also going to demonstrate it as to how exactly it is carried out.
So, since this technique, as the name suggests, is based on ultrasonic waves. So, let us first see what ultrasonic waves are and what their properties are, and then we are going to see how these waves are used for doing NDT. Okay. So, let us first learn little bit about ultrasonic waves. Ultrasonic waves are nothing but sound waves which have frequency greater than 20 kilohertz. Okay. So, anything below 20 kilohertz would be in the audible range. When you go to a frequency beyond 20 kilohertz, then the sound waves are in the ultrasonic range. Okay. So, this is what ultrasonic waves are. Now, let me tell you how these ultrasonic waves are used for doing NDT. The basic principle behind this is fairly simple. We all know about reflection of sound waves or the echo of sound. Like for example, if you talk loudly in an empty room, the walls will reflect the sound and you will get an echo. Okay. So, while doing ultrasonic testing, what is done is these ultrasonic waves are sent into the sample, and when these waves are reflected back, they are collected by a transducer, which finally will generate the signal if there is any defect. Okay. So, this defect will also act as a reflector which can reflect the sound waves. Okay. But in that case, the reflection interface is much smaller compared to a wall. So, that means the energy which is there in the reflected waves should be enough for the transducer or the instrument to collect this signal back. Okay. So, if you have enough energy in the reflected wave coming out from a flaw, then this can be easily captured through an instrument, and then you can generate a defect signal and get the indications about the presence of defects and flaws on a given sample. Okay. So, this is how the ultrasonic waves can be used for doing NDT. So, this is primarily based on the sound echo or reflection of sound waves, reflection of ultrasonic waves from the discontinuities which present a scattering interface for reflecting the sound waves. Okay. So, if you have the instrument, if you have means to capture this reflected beam coming out from the sample or coming out from a defect, then as I said, you can use that to do NDT and get indications of defects. Okay. So, all you need for doing ultrasonic testing is an ultrasonic transducer, which will generate the ultrasonic waves, and you need the instrument which will have all the electronic circuit and everything necessary to capture the echoes coming out from the sample, and with the help of that, if there are any echo which is coming out from a defect, you would be able to see them in terms of a signal or a peak. So, you take the transducer and keep it over the sample. Okay. And so, this transducer we will generate the ultrasonic waves. So, these waves will go like this. So, they will go to the other surface, hit the back wall and come back. Okay. And in between, if you have any defect somewhere, okay, so these waves will also be reflected from this defect in that fashion. Okay. And this will generate a signal like this in the time base, and let us say this axis is the amplitude. So, what do you see? First you have this initial pulse what is being sent into the sample, and then these ultrasonic waves will go and hit the back wall, the other surface of the sample, and from the back wall you will get this back wall signal. Okay. Right. So, this is your reference frame for getting the defect signal. You have the initial pulse in the beginning and you have the back wall. Okay. And this instrument will capture this time that the waves take to go all the way to the back wall and come back, and that is what is plotted in terms of the intensity of these pulses or the intensity of the reflected signals. Okay. So, if you have a defect like this, so that will come in between the initial pulse and the back wall, because the defect is lying between the top surface and the bottom surface. So, you will see a defect echo like this. Okay. Right. So, this is how the defect signal is generated with the help of ultrasonic waves. So, if you have the means and ways to capture these echoes coming out from the small interfaces of the discontinuities, then you would be able to get this defect echo, and then you will have the display system in terms of an oscilloscope screen or things like that. The whole thing can be displayed, and then you would be able to know if there are any defect, that defect signal will come between the initial pulse and the back wall signal.
So that was about the basic principle of ultrasonic testing. Now let me demonstrate it using this video, which was captured on live experiments which were carried out in our NDT lab. So this is how the instrument looks. You can see different press buttons over here on this panel, right? So these are the buttons using which you can control certain things on the instrument. These buttons may vary from model to model, but the basic function of the instrument will remain the same. Okay. And here you can note a very important option that you have in this instrument, and probably in most of the other instrument also this is going to be there. These numbers that you see over here, these are basically the velocity of sound waves in different materials. Okay. So you have a set of preloaded velocities here that you can choose from depending on the material of the sample which is being tested. Okay, so you can see different types of medium or materials are listed over here. You have water, then you have carbon fiber, steel, cast iron, stainless steel, titanium, aluminium, and so on. So depending on the material of the sample, you could choose the appropriate velocity from this list. Okay, and that will be displayed on this window over here. Okay, so that will actually convert your time of flight that the instrument captures directly into the depth or distance, which can be seen in the x-axis over here. Okay, so first we are going to see how the distance is calibrated, because for ultrasonic testing or any other NDT method where the indications or the results are indirect, calibration is very important. Okay, so before you do the testing, it is important to calibrate the instrument. So that is what we are going to see first, and that will also give you an idea as to how exactly the ultrasonic testing is carried out. And we are also going to use some sample or some kind of standard blocks having standard known depth or distance to show how the display of the signal will come from a particular distance. Okay, so let us first see how this instrument can be calibrated, and as to how exactly it is done, using different buttons that you have. That process may vary from instrument to instrument, from make to make, right? But the objective is to calibrate the instrument and the ultrasonic transducer at the end of the process. Okay, so let us go ahead and see that first. So this is how the echoes or the signal will appear on the screen. So these are two back wall signals that you see, which is basically coming out from the thickness of the sample. So it is going, the sound waves are going through the samples and getting reflected from the back wall or the other surface, the back surface, and coming back to the transducer and being displayed on the screen. Okay. So as I said, since you have chosen the preset velocities, the time which is being captured by the sensor will be converted into distance. So this x-axis is distance now, distance or depth, and you can see this peak at a particular distance corresponding to the thickness from where this echo is coming. Okay. And let me also show you some of the transducers, the ultrasonic transducers that we have. So this one that you see over here, this is a normal probe. Okay. And then we also have some angle probes that I'm going to show you right now. So this is having a particular frequency. And this one that you see over here, you can see two elements, right? These two white crystals over here. So that tells you that this is a dual element probe where you have two crystals or two active elements. Okay. So that is sometimes necessary to get better results. If you have two elements, your reception of the signal may be better. Now let me show you some of the angle probes that we have. So this one which is picked up, you can see this is a 70-degree angle, right? This is a 70-degree angle probe. Then we have another one over here. This is a 60-degree angle probe. And the third one that we have over here is a 45-degree probe. Okay. Now let us see how the calibration is carried out. So for this, we are going to use this straight probe or the normal probe. And we are going to use this block having a particular thickness. So this is basically an aluminum step block having steps of different thicknesses. So this step that you have over here, this is having a thickness of 14 mm as being shown over here. As you could see, it's a 14 mm thickness. So we are going to use that to calibrate the instrument. So the first step here is to set the x-axis so that the given depth of the sample can be displayed properly in the display. Okay. So according to the thickness or the depth which is being measured, the x-axis has to be set, and that can be done by using this menu over here and setting the range and delay buttons. Okay, so changing the range and the delay, you can actually set the x-axis so that the chosen thickness of the material is being shown properly in the display, as I said. Okay, so that's the first step. So that can be done using this cal menu or the calibration menu over here. Okay, as you could see. Okay, so once the x-axis is set, once the proper range is set, then we are going to carry out the other steps of the calibration. So in the next step, the frequency is set. The frequency will be chosen according to the frequency of the transducer that you are calibrating. And here we are going to select a particular mode for the signal. So here in this particular model, it is selected as RF. So the frequency is set, as you could see, depending on the transducer which is chosen. So that a transducer will have a particular frequency. So that frequency is set over here. And after that, you will also have to select whether it is a single or dual element probe. So this is where you can do that using this particular press button. Okay. So we have selected a single element probe. So this is going to be set as single, as you could see right now. This was set to single. And now we are going to carry out the calibration. So keep the transducer on the sample of given thickness, and first you get a proper shape for the echo. Okay. So that can be done by controlling two press buttons over here from this TX menu. Okay, in this particular model. So here we are going to control the width parameter, that is one of the parameters, to get a proper shape for this echo, right? And in order to obtain a proper shape and width for the echo, this edge parameter can be controlled. So that is what we are going to do next, so that a proper echo shape can be obtained. All right. And after that, we are going to come to this amplification menu and go to the detect parameter and set it to full here. Okay. And now, in order to make sure that these echoes properly fill the screen of the display, this contour parameter is set. Okay. So how much this echo will occupy the space over here on this display screen, that can be set, so that you get a proper filling of this space over here on the screen by these echoes. So the contour parameter will be set now in order to do that and get the proper filling of the echoes on the display screen. Once you do that, you would see that this echo is getting a proper shape with a desired width that you want. Okay. So now we can use the gain parameter to make sure that this echo is having enough amplitude on the display screen. Okay, so a little bit of gain can be provided so that the height or the amplitude of this echo is high enough to fill the display screen. Okay, so some gain is provided, you could see over there. Okay, so this will set the instrument for proper receiving of the signal from the sample. Okay, and whatever signal is received, that will be properly displayed because we have set all the parameters in the steps which were carried out. Okay. So now we will go to the measurement. So here you can see there is a measurement menu. So now we are actually going to capture the echoes from the sample of known thickness. So here we need something which will indicate that what depth this echo is coming at, okay, on this screen, right? So for that we are going to use a parameter, or there is an option here called get, okay? Get is nothing but it is basically a marker which can be put over an echo and it will display the depth at which it is occurring. So you can see the depth or the distance corresponding to the get as you put it over a particular echo. Okay. And in order to ensure that the distance is appearing properly and the instrument or the probe is calibrated in terms of the depth of distance, we are going to select two gates, gate 1 and gate 2. We'll call that as G1 and G2 as per this particular model. And that can be put over here as mode, and the mode can be selected as G1 minus G2 so that the difference between these two gates can be read. So the distance between these two gates as you put them over two peaks can be easily read, and that will give you the distance between two known thicknesses, and you would be able to figure out whether it is appearing at a proper depth according to the thickness of the sample. Okay, so let us go ahead and do that. Select the gates and change the mode to G1 and G2. Yeah, so that is what is being done over here. You could see it is being selected as G1 minus G2, and this G1 minus G2, this distance can be read over here, okay, on this place on the display screen. So this one that you see over here, this is written as G1 minus G2. So this one that you see, this is basically G1 minus G2, and we have chosen the scale in terms of millimeter. Okay, so you will see the distance over here, okay, in terms of millimeter. And now, as I said, once you set the gates and you read the distance from here, distance or the depth, you would be able to know whether it is coming at the proper depth or distance. If it does not, then you will have to change few parameters over here to calibrate the instrument and the transducer. All right, so we are all set now to collect the echoes from a known sample thickness, and this is what you can see from here, these are basically the back wall signals. There are multiple back wall signals. We have chosen the range or the scale on the x-axis in such a manner that multiple back walls will appear on the display. So that's what you see from that 14 mm thickness. And this 1 and 2 that you see over here, these are those two gates, gate 1 and gate 2. So this is G1 and this is G2. So if you put these two gates on two peaks, it will show the distance between those two peaks, and you can read it from here as it is shown as G1 minus G2. Okay. So let us see whether it is coming according to the 14 mm distance or not. Okay. So gate 1 is being fixed right now on a particular back wall echo. So this is probably the second back wall. The first one will be on the further left, which is not being shown right now. So the second back wall is supposed to come at 28 mm, okay, because it's a 14 mm sample thickness. It is unlikely that it will come exactly at that distance, because this distance is being displayed over here according to the preset velocities that you have in the instrument. Okay, and the actual velocity in the sample can be little different from the preset velocities that you have preloaded in the instrument, and therefore there could be a little difference here, but that is acceptable. Okay, because we know there is a difference between the actual velocity and the preset velocity, but that difference should not be significant. Okay, if it is a significant difference, then you have to worry about it and set few things to set it correct. So now let us go to gate 2, put it on another peak. So we have chosen these two peaks, second peak for gate 1 and the third peak for gate 2. So the distance between any two consecutive back wall peaks should be close to 14 mm, and let us see whether it is coming as 14 mm or not. Yeah, that's what you see over here, right? G1 minus G2 is very close to 14 mm, 14.4 mm, 45 mm, which is quite good. Now let us see for the other higher order reflections also, the higher order back walls, whether those are also displayed correctly or not. So we'll take this gate 2 to the higher order back wall echoes. So right now you could see it is being put over this peak where gate 1 is there. So when both the gates are on the same peak, G1 minus G2 will be 0, and that is what you see over here. Okay. Now as you move gate 2, the distance between these two gates will be shown over here, okay, as G1 minus G2. So let us move this gate to rest of the back wall reflections and see whether the distance is shown properly here or not. So right now it is on the next back wall. So the distance between these two consecutive back wall should be close to 14 mm. So this is very close to 14 mm, around 13.8 or so. Let us move it to the next. It should be 28 mm for the next one. Yeah, so that is what you see. This is close to 28 over here. right? So this is around 28.9 mm, which is quite good. Move it to next. The next one should be close to 42 mm, and that is what you see. So this is the third one, right? So the third back wall means it is 3 times 14, so that should be 42, and that is what you see over here. This is very close to 42 mm. Okay, now let us go to the next ones also. Next one should be close to 56. Yeah, that's what we see over here, and so on. Okay, so this tells us that the instrument is correctly calibrated right now in terms of the depth or distance. And we could also verify that, using a single peak. Okay, instead of using two markers or two gates, we can use one single gate and see that a particular peak is appearing at what depth or distance. Okay, so if you put that marker or the gate on a particular peak which is coming out from a known distance, you would be able to read it from here. Okay, so we can change the mode from G1 minus G2 to only depth, and switch off gate 2 and read only gate 1. Okay, so that will tell us whether the depth or the distance is being properly coming onto the transducer and being displayed here correctly or not. Okay, so let us go ahead and do that. Yeah, so again, we are going to use this 14 mm thickness as being shown right now. Yeah, so this is the 14 mm step that we have, and this is the normal probe, the same probe that we just now calibrated. So let us see after the calibration whether it is showing us the correct distance or not. Yeah, so now we have only one gate, as you could see, and the mode is changed to depth instead of G1 minus G2. So here you would see it as D, which stands for depth or distance. Okay, so right now it is being put over here. It is being placed here on this particular back wall. So this is the third back wall over here, and it should be close to 42 mm. Okay, and it is actually, if we move it little bit on the left side, it will become very close to 42 mm. You could see the value over here, the depth. Now let us see for the other echos also, the higher order back wall echos. So one thing you will have to do here in order to make sure that it is coming at the proper depth where it is supposed to come, you will have to set the x-axis. Okay, if it does not come at the proper depth where it is supposed to come. So once you switch off gate 2 and come back to only this gate 1 mode, the depth mode, then you will have to first see, as I said, whether a particular echo is coming at the depth where it is supposed to come, and if it does not come, you will have to give some offset. You will have to offset that difference by using this 0 that you have here. Okay, so this 0 has to be set. This 0, you have to give some value over here in order to make sure that this peak comes at the proper depth. Okay, this is to take care of the distance that you have between the front face of the transducer and the active element. If you have noticed, when I showed you the transducers, there is a front face where you have a protective shoe to protect the transducer from wear and tear, and the active element is little inside. Okay, so there is a distance, there is a finite distance between the front face, which is touching the sample surface, and the active element, right? So in order to take care of this distance, you will have to set this 0. Okay, so that the first back wall and the later ones also come at proper depths. So that is what is done. A proper value for the 0 is set over here, and then this is being checked whether it is coming at the appropriate depth. Okay. So once that is done, once the 0 is set, then this gate will be moved to other echoes also, just to check that the depth is being displayed properly. So now we are moving this gate to higher order back wall echoes, and you can see the corresponding depth here. Okay, so if this is the 14 mm thickness that we are talking about, then you know for each of these higher order echoes what should be the depth. For example, if it is the fifth one, so if this is the second one, then this is third, fourth, fifth. This should be close to 70 and so on. Okay, so that is what is being checked right now. 70, then 84 and so on. So these are coming more or less at proper depths. So our instrument is now calibrated and you are ready to go for the testing. All right, so the instrument is now calibrated and you are ready to go. So we are going to take up some other sample also and just see whether it is showing the proper depth or not. And in order to do that, we are again going to select the same transducer, the same transducer which was used to calibrate. So this transducer is now calibrated, and now we are going to use a different sample, a different depth, and then we will see whether it is showing proper distance or not. Okay, so for this purpose we are going to use this cylindrical block which is made of the same material. So the previous one was done using a particular material, the calibration that just now we saw. So in order to use the same calibration, the material has to be same, right? The sample material and the standard block which is used for calibrating the instrument must be same, right? So previously we used an aluminum block, and therefore this one also has to be made of aluminum. So this is an aluminum cylindrical block having a known height. So we are going to use that height as the back wall. So let me show you what is the height. So you can see this is having a height of 8 inches or 200 millimeter. And apart from that, you can also notice few other features on this cylindrical aluminum block in terms of these small holes which are drilled on the block. Okay, and you have more than one hole at equal distances. So here you can see this is at 50 mm from the top or from the bottom, and here again you can see one more line. So along that line on the other side you have one more hole at equal distance. So from this hole to the second hole it will be again 50 mm. And here also you can see one more line. So along this circumference also at this distance also again 50 mm apart from the second hole. you will have another hole drilled on this block. Okay. So apart from this back wall signal, if the transducer is kept right over these holes, at an appropriate place on this top surface, you should be able to see some echoes corresponding to these holes also. So let us see what is being displayed on the screen as we put this transducer over this block and start capturing the signals. That's what you see. You see these big peaks. These are basically the back wall echoes. So the distance between any two consecutive back wall echoes should be 200 millimeters. So let us see whether that is coming properly or not. So we are going to use these two markers again, gate 1 and gate 2, and see whether we have a proper depth or distance here, whether the instrument is calibrated or not in terms of the distance. So let us set the range. So this is to set the x-axis as I have mentioned before also, so that a number of back wall echoes appear on this screen. So after setting the range, you would see that these back wall echoes are appearing. And in between, you also see these small echoes over here. Basically, you would see three smaller echoes. These correspond to those three holes that I mentioned. Okay. So let us see what is the distance between any two consecutive back wall echo, whether it is close to 200 millimeter or not. Okay, so we are just going to set the gates for that, gate 1 and gate 2. So the gate 1 is moved right now and it is being put over the first back wall echo. Let us move the second gate now and see what is the distance between these two gates. Okay, so the second gate will be placed over the next back wall and let us see what is the distance, that is G1 minus G2. It is being moved to the third one and the third one should be 400 mm, right? So this is what you see. This is very close to 400 mm. The distance between the first back wall and the third back wall should be 400 mm, and that is what you see over here. Okay. And if it is on the second one, if we put gate 2 over this one, then it should be close to 200, right? So let us see that. So right now both the gates are on the same peak and therefore G1 minus G2 will be 0, as you could see over here. Okay. Now let us move this gate 2. And as it comes to the next back wall, you would see the distance is 200 mm, very close to 200 mm. So that tells us that the calibration that we carried out was done properly, and that is why the distance is being now displayed properly on the instrument. Okay, so this is how you do the calibration for the ultrasonic testing. And as I mentioned before, these smaller peaks that you see over here, these belong to those small holes which are drilled on the circumference of the cylindrical block. All right, so that is how you calibrate the instrument, and once it is calibrated, you are good to go for doing the ultrasonic testing. So I hope you liked the video, and if you did, please subscribe to the channel where you would get many more such useful videos that might be helpful for your career. Thank you for your time to watch this video.